Hello everyone, I hope you're all doing well and you're ready for more of our 2012 Fermat paper. We are on question number 18. If n is the smallest positive integer whose digits have a product of 1728, which actually is not a common but a fairly well-known math number. This happens to be 12 cubed. You see it around every once in a while. Anyway, so the digits have a product of 1728. Then the sum of the digits of n is. Okay. So we're going to have to try and construct this n, and we want n to be the smallest. This is very easily a question that I could see myself back when I was doing contests misreading. Okay? If you race through it, you think then you know what they're talking about, you might accidentally say, all right, we need an n whose product is 1728, and we need it to have the smallest possible sum of digits. So smallest and then sum get linked in your head. And so then even if we come up with an answer of 28 or 27 or something like that, we might not be satisfied until we get a lower number like 18. Except we don't actually care if the sum is big or small. We care if the n we make is small. Okay? So we want to watch out for that. Okay? We don't want to be tempted to look for smaller answers. What we do need is smaller n's. That's what we want. And then we'll take the sum of the digits. All right, so how do I make a small positive integer who's got sort of a specified product for its digits? Okay. Well, what sort of numbers do you want? And you might think, oh, I want a small number, like, 1001. That's a pretty small number compared to something like 2345 or 9876. And that's true. Small numbers can be nicely ordered, so that you well, let's make these twos or something in here. Small numbers can be nicely ordered and to give you very small numbers, but it's not as good. So here the product is 4. This isn't as good as if I just had 4 or 1 4. Okay, using bigger numbers is okay because we get less digits overall, but we still have the same product. Okay, so yeah, small numbers are nice because you can put the small numbers up front and that makes a smaller number. But you don't want to do that at the cost of adding more digits. Automatically, a 4-digit number with small digits, with small single value digits, is still bigger than the biggest 3-digit number here that uses really big numbers like 9s and 8s and 7s. So our strategy for making n is we're going to figure out, all right, so 17, it doesn't take too long to realize, okay, 1728, let's factor this. And it's 12 cubed. You work out with your calculator. It's 2 to the 6, 3 to the 3. And it's 12 times 12 times 12, or 64 times 27, whatever you want to say. What we want to do, we need our numbers to multiply all to this. One thing that's pretty quick to see, you don't ever need a 1. 1 doesn't help you. But what we're going to try and do is we're going to try and sort of absorb as much as we can into a single digit as possible. So rather than this 64 here, rather than me using 3 4s or 2 4s and some 2s or 6 2s, I can write it using only a product of 2 digits. Now they're big digits, yes, but there's less of them overall. Okay, so automatically I'm getting smaller numbers just because I have less digits. So let's see what we can do with an 8 and an 8. And then how can I make this 3 to the 3? Well, I suppose we could have, that's 27, so we could have a 9 and a 3. All right? So we could make a number like that. So 3, 8, 8, 9. That's my current best n. Okay? Now we've got 4 digits, so automatically anything with 5 digits, 6 digits is going to be bigger than this n. Is it possible to get something smaller? Okay. Well, something smaller would need to start with maybe a 3, but then a smaller next digit, or maybe a 2. Can't start with a 1. Okay. Now, could we perhaps get a 3-digit number? That's something to think of. Is there a way to do this with 3 digits that I'm just not seeing? Okay. The biggest 3-digit number is 999. And this also has the biggest product. 9 times 9 times 9 is 729. That's far smaller. So we can see, all right, you're not going to have 3-digit numbers, but maybe there's a smaller 4-digit number. So can we tinker with what we've got? Absolutely, we can try and tinker with it. I could take one of the 2's from the 8, put it with the 3, and I can get 8, 4, 9, and 6. That, the smallest n you can get there is a 4, 6, an 8, and a 9. Okay, that's not going to work. So what did we say? We need at least to start with a 3 or a 2. Well, could I get it to start with a 3? So we'll keep this 3. Is there a way to redistribute these factors to get something less than an 8? Well, if I took one of the 2's away from an 8, I can't put it with the other 8. And I can't put it with the 9. So it looks like if you're going to start with a 3, you're stuck with 8, 8, 9. Okay, well, maybe I can do something with the 2. So let's take 2 of the factors of 2 from this 8. I can't put them with the 8, then we'd get 16 or 32. I can't put them with the 9. I can put one of them with the 3, but I'll have an extra factor of 2 left over, and I can't turn this into a 12. So it doesn't take too long to convince yourself that the 2 won't work. Now, if you're not happy with this sort of argument of, well, I tried it and it didn't work, one other thing you can say is, all right, suppose I had a 2. What could the other 3 digits be? A, B, C. What's the product of A, B, and C going to have to be? Well, it has to be 1728 divided by 2, right? So it's going to have to be 864, right? Can I get a product of 3 positive numbers that gives me 864? Well, we can try, but, I mean, all right, 864, that's 2 to the 5 and then 3 to the 3. Unfortunately, you're not really going to... so here's what you can do. You can take the cube root here. The cube root of this is then bigger than 9. Right? Because notice, if A, B, and C were all 9s, the best you could do as a product, that's the best you can do for a product of 3 single digits, and that's 729, and that's still smaller than the cube root of it, than 864. So if you've got a 2, that A, B, and C would have to be, one of them would have to at least be bigger than a 9, and that just doesn't work out. Okay? So that's if you want to go a little more in depth. I wouldn't. I would just say, all right, I convinced myself that 2 isn't going to work. I tried a little bit to experiment with a better 3. It just isn't going to work. Eventually, you just say, all right, no, that's it. This is the number I'm going with. And that is the smallest n that we can make that has a product of digits be 1,728. Okay? So however long it takes you to realize that, to confirm that, to be confident in that, we have to finish up the question. 3 plus 8 plus 8 plus 9 is 28. I believe that was one of the answers. Yeah, it's A. It's also the biggest one. So you might get that 28 and then accidentally see the word smallest out of the corner of your eye and say, oh no, I need to keep retrying until I get something smaller. And you start pulling your hair out at that point because you're stuck in a loop. I need smaller n's, except now I need a smaller sum, except then I could find a smaller n, and you'll never be satisfied. So there we go. Make sure you read questions carefully. You can think through them, but don't waste too much time on them. And our answer here turned out to be A. All right. So I think that's it for me right now. Up next will be question number 19. So feel free to join me for our 2012 Fermat paper, question 19, next time.